Hello everyone, this is class 5, part 2. As I was saying in the last video, it doesn't matter what angle and magnitude of your armature current, the projection on the voltage V is always constant. That means this part is always constant. If you multiply this part with the voltage, you get constant power. So your power over here, VI a cosine theta, doesn't matter what theta is, you get a constant power. That's how your generator supplies a constant power to you. And on doing that, if you look at here, doing that, how do you go from leading to lagging power factor? Like if this is the lagging over here, this is the leading over here, so it's lagging, leading. Here, how to go back? You can do that by controlling the field current. Remember that rotor has a field current, DC field current. That field current basically can take you from leading to lagging through the unity power factor. So this is the unity power factor over here, and this is the leading, this is the lagging. And in the leading side over here, you have your EV. If you have leading, EV is less than terminal voltage V, and your lagging, you have EV is greater than V. So this is called overexcited. It's called underexcited. All right. So this overexcited mode is underexcited mode. I'm gonna talk a little bit about that in the next slide, what that means. All right. So again, same thing we're showing over here. So now by doing this, you can, by going from lagging to leading or leading to lagging, you can basically control reactive power flow from the generator. Why is that? Remember that reactive power flow depends on voltage magnitude. Right? So by varying the field current, you can make it leading or lagging. In a lagging power factor generator mode, which is overexcited, your excitation voltage is higher than your bus voltage. That means your reactive power is supplied by the generator. When in leading power factor mode, your excitation voltage is lower than your bus voltage. That means your generator is consuming reactive power. So over here, as I said, this is overexcited mode over here, like overexcited mode. E is greater than V, that means you're supplying the reactive power. And over here is underexcited mode, you have E is less than V, that means you are receiving the reactive power. So how is doing this? You're basically changing the field current over here, field current to the rotor. And by controlling the field current to the rotor, you can go from receiving the reactive power to supplying the reactive power. All right, and that's how your generator works. It could be either receiving the reactive power or the supplying the reactive power. So this is the a simple model over here. We're assuming that R equal to 0. If you do that, and this angle become 90 over here, so this is your three-phase power supplied by the generator, and this is the reactive power. Again, it depends on magnitude of E. If you do leading power factor E is smaller than V, then you receive the generator receive the reactive power. If lagging power factor E is higher than V, then generator is supplying the reactive power. But it doesn't matter, you're receiving or supplying the reactive power, your real power supply always constant. All right, as long as you keep this angle constant over here. All right. So now again, theoretical max power P max would be 3 times E V over XS, what is delta is 90 degree. And if I draw this, let me draw this one here if I can. So this is your power max over here, right? And this is the angle delta over here, and this is your 90 degree. So what happened here, once you supply more and more mechanical power to the shaft, is accelerating and your delta increasing and you're getting more and more power, right? You're getting more and more power. But when it reached 90 degree, you supply more and more mechanical power, your delta increasing, but your power decreasing here. So this is the unstable region. And so this was unstable, this was stable over here, right? So what happened over here, if you go beyond 90 degree for delta, then your generator is out of synchronization and you need to pull it out from the grid and put it back to synchronization again before you put it back to the grid. So this is basically your generator is out of the grid connection, all right? So for the reactive power, when delta is too small, then you have 3V over XS. Over here you have E minus P, right? So over here you can see that this will guide your reactive power flow. For lagging power factor, reactive power is supplied by the generator. For leading power factor, your generator is receiving the reactive power. So that's what I said over here. That's what's happening with the more and more mechanical power coming in, and if delta goes beyond the 90, then you cannot be in the synchronization anymore. Again, so for this one over here, this is your generator supplying reactive power. All right, this one is receiving reactive power, as I said. All right, and this is the over-excitation mode. This is the under-excitation mode. And normally, your generator works in the over-excitation mode, supplies reactive power, and so generator also the main source of reactive power for the transmission line, because transmission line is mostly inductive and supplies a lot of inductive load, so you need more reactive power supplying from the generator. And reactive power flow also governed by this equation, you know that by voltage, and your real power flow only governed by the angle difference between the generator terminal to the bus. We're going to do this problem in the class. All right, that's all for this. Next one, we're going to talk about the transformer.